So now that we know how to draw a graph that shows relationships between objects, for this example, we're going to explore some key features. So here we have this graph, and we know that in a graph we have these points here, and these points are known as vertices. And then the connections between the points, those are edges. So for here it says use the graph to identify the following features. So for A it says list the even vertices. So if we go to this vertex here, vertex A, what makes a vertex even or odd for that matter is the number of edges that emanate from it. So we have 2 edges that spring from this vertex here. So since there are 2 edges, that means that this is an even vertex. For B here, we have 1, 2, 3. So this one is odd. For C, we have 1, 2, 3. So this one is also odd. For D, we have 1, 2, 3. D also has a loop. A loop is identified where it begins and ends at the same vertex. And a loop is always counted twice. So we have 1, 2, 3, and since the loop is counted twice, this has 5 emanating from it. So this is odd. E has only 1, so that's odd. F has 1, 2, 3, so that's odd. And G has only 1, so that's also odd. So it seems as though the only even vertex is A. So I'm just going to write it right here. A is the even vertex. B says list the odd vertices. Well, if A is the only even one, then all the other ones are odd. So that's B, C, D, E, F, and G. C says list the vertex that has a loop. So D is the one that has the loop. Again, a loop is an edge that begins and ends at the same vertex. So list the vertex that has a loop. That's D. D here says determine the degree of vertex F. The degree is the number of edges that emanate from it. So this one has 1, 2, 3. So then F has degree 3. Now E says list the edges that are bridges, or the edge that is a bridge. Now a graph is a connected graph. I'm going to put it right up here. Is a connected graph when you can get from one vertex to any other vertex along an edge. I can get from C to D. I can get from D to A. So if I can get from one vertex to any other vertex, that's a connected graph. Other than that, it would be a disconnected graph. That's where I can't get from one vertex to another. So what would make a connected graph a disconnected graph? That's if I took away an edge. That edge would make the graph disconnected. So if I took away this edge here, I can't get to vertex G. So one of the bridges would be this one here. I'm just going to list it as FG, and that's how we write it. That's a bridge. Another bridge is this one here. If I was to get rid of that edge, it's not possible to get from one vertex to E. So it makes it a disconnected graph. So we can say CE or EC, however you want to write it. is also a bridge. And then for F, it says determine a circuit. Now there's a number of circuits on here. We're just going to do a couple of them. So one potential circuit would be A to B, B to C, C to D, D to F, and then F to A. And of course, we know that a circuit begins and ends. It's where a path begins and ends at the same vertex. So I would list this as A, circuit A, B, C, D, F, and A. If this is a circuit, it's got to start with the vertex and end with the same vertex. You have to be able to delineate. If I didn't write this, that means that this one wouldn't be there. Another possible circuit could be B to D, D to C, and C to B. So we would write that as B, circuit B, D, C, and I have to end back at B. But there's a bunch of them. And there you go.